In the last part of our lesson, we saw how we can write radical expressions using rational exponents, or that the denominator of an exponent is the index of our radical. We can combine radicals and exponents, whole number exponents, such that I can look at an expression raised to the power m over n, m divided by n. The m in this expression acts like a normal exponent. So the numerator on our fractional exponent acts like a regular exponent. The denominator is the index of the radical. The same restrictions apply. If n is an even positive integer and a is negative, then a to the power m over n is not a real number. Looking at a few examples, 25 to the power 3/2 we can write as the square root of 25 cubed, or the square root of 25 cubed. Both of these expressions are equivalent. If I try to raise 25 to the 3rd power, I get a really big number. I can then take the square root, I get 125. Or I can take the square root of 25 first, and then raise it to the power 3. I get the same answer. If we needed to do this by hand, the easier one to do by hand is to do the radical first and then the exponent. So you'll see me do that more often because it's easier for me to do these problems without a calculator if I do that radical first. Just because I'm not using a calculator sometimes doesn't mean you can't. You're allowed to use a calculator, so go ahead and use it. It'll check your arithmetic. Make sure you're doing the right steps. 64 to the power 2/3, we can write it as cube root of 64 squared, or cube root of 64 squared. I'm going to do the latter because, again, that cube root of 64, I know that is 4, and 4 squared is 16. We can also do this in our calculators as a way to check by entering 64 to the power 2/3. 64, I'll hit my power button here, x to the power y, and because I have a fraction, I'm going to put it in parentheses. 2 divided by 3, close parentheses, there's 2 divided by 3, hit equals, and there's my answer, 16. Since we can write all roots as rational exponents, all these rules of exponents exist for us in terms of radicals as well. Since all roots can be written as rational exponents, all of these exponent rules are still valid for us. We need to know how to use them. So in the next part of this lesson, I'd like for you to take a moment and practice using these rules in these next groups of problems. I will leave the first 4 for you to try on your own. Pause the video, try them, and when you resume, I'll have the answers for you. Remember how important it is to try it on your own, and if you make a mistake, correct it and learn from it. That's how we learn. So pause, try it on your own. When you resume, I'll have the answers and we'll do number 5 together. Okay, take a moment and check through your first 4 problems. See if they match mine. In problem number 5, let's see how we could simplify this exponential expression with rational exponents. We have x to the power 6 divided by 27, all raised to the 2/3 power. So I can use the expanded quotient rule and take this 2/3 and apply it to both the numerator and the denominator in this fraction. Now here, the x to the 6th to the 2/3 power, when I have exponents together like this, an exponent raised to an exponent, this is the expanded power rule. I need to multiply them. So I will multiply 6 times 2/3. I'll write 6 as 6 over 1. I can cancel factors of 3, and I'm left with 4. So the numerator here, x to the 6th to the 2/3, becomes x to the 4th. 27 to the 2/3, I can use that exponent and rewrite it as cube root of 27 squared. Well, the cube root of 27 is 3, because 3 times 3 times 3 is 27. And then I need to square it. 3 squared is 9. So for number 5, simplifying the expression down, the simplest I can get is x to the 4th over 9. Let's try number 6 together. Number 6 has a negative exponent here, negative 1/3. It's a little hard to see, but there is definitely a break between these two lines for that 1/3. So negative 1/3. I can first use the expanded exponent rule and take the reciprocal of my fraction. So the negative exponent means the top and the bottom switch places. I still have the 1/3 exponent because I didn't do anything with the 1/3. I only used the negative sign of the exponent. Keep in mind, a negative on the exponent has no effect on the sign of our expression that's being raised to it. The negative exponent means that we need to take a reciprocal. Things are not in the right place in the fraction. So now this problem looks a lot like our previous one. We can take the 1/3 and apply it to the numerator and the denominator, just like the expanded quotient rule again. And now we need to multiply these exponents. 6 times 1/3, cancel out the 3's, and I'll get 2. 3 times 1/3, cancel out the 3's, and I get 1. So the numerator becomes y squared. The denominator becomes x. Y squared over x. Number 7, we're adding to the complexity of the problem, making it a little bit more complicated. Here in this problem, there are several negative signs, and they're occurring in specific places in our expression. A negative exponent simply means the expression is on the wrong side of our fraction bar in the problem. So what we need to do is take the x and the y terms up top and move them to the bottom, and we need to take the x term on the bottom and move it up to the top. That y squared is going to stay where it is because its exponent is positive. We don't have to move it. Sometimes I say that the negative sign is like putting the expression in timeout. It's in the wrong place, it's been naughty, we need to move it to another place. I don't know if that helps. Hopefully it does. But the negative sign means we need to move it. So take the reciprocal. Take the reciprocal means move it to the other side of the fraction bar. So let's do that first in our expression. We'll move everything around and leave the 1/2 exponent outside. So the x to the -2 goes up top, and once it moves, we use up the negative sign on the exponent, so it changes to positive. X to the -6 will become x to the 6th. Y to the 4th becomes y to the 4th. But this y squared here is going to stay where he is. We don't move that one. There's no negative on the exponent. We don't need to move it. Small simplification with the y's. We can add the exponents together. 4 plus 2 will give me 6. And then I can apply the 1/2 exponent. Applying the 1/2 exponent in the denominator means that I can use, I don't have a rule written up there, but I have the ability here to apply this 1/2 to both of these factors, x to the 6th and y to the 6th. So I'm going to do that. It is a rule, but I think I left it off my list of rules, and we use this one a lot. It's the same idea as we have for our expanded quotient rule. We have one similarly where we're multiplying things together, and we can distribute the exponent inside. Okay, so x 2 times 1/2 is going to give me 1. 6 times 1/2 will give me 3. So I have x to the 3rd, y to the 3rd. That's not my final answer. I have extra x's in here. I have an x on top and an x to the 3rd on the bottom. I can cancel those out. So this is not my answer. I need to do one more step. And it actually turns out that if you're applying these rules, you can apply them in a different order. As long as you're doing everything the way that you're supposed to as the rules are written and using them properly, there are lots of different approaches to this very same problem that will land with the same answer. So if your steps are different from mine, you're using the rules like you're supposed to, and you end up with the same answer, then it's a very good chance that you did things correctly. So here we need to cancel out one of the x's on top with x's on the bottom, or we can look at this as a subtraction. So I'm focusing in on the x over x to the third. X to the third, 3 minus 1 will give me 2. So I have x squared on the bottom with y to the third along with it. That's as simple as I can get it. And I am subtracting, I'm really looking at this, as 1 minus 3 will give me negative 2. The negative 2 just means that the x needs to be on the bottom and not the top. So using that quotient rule that we had before, we can do that. I could have canceled the x's up here too in a different way. I'd still end up with the same answer. That's an example where there are different steps that we can use to complete the same problem. Numbers 8 and 9 are similar, so I will look at number 9 and I will let you do number 8 on your own. If you want to take a look at problem number 8's answer, check out that OneNote link. For number 9, we can look at the inside part and turn that into its equivalent exponential expression, x to the 1/4. So the fourth root of x is equivalent to x to the 1/4. Then that radical that comes on top, it has an index of 2. So we're looking at a square root, or to the 1/2 power. Now I have an exponent raised to an exponent. I need to multiply the exponents. Multiplying fractional exponents works in the exact same way as multiplying fractions. Straight across. 1 times 1 is 1. 4 times 2 is 8. So I have x to the 1/8 power, or the 8th root of x.